Okay, so on test 3, on the first page, the biggest issue was just counting days on 2 and 3. But for 4 and 5, there were a couple of questions, just setting up the equation. Interest equals PRT. Both of these involve finding something other than I, which is what we're used to finding in these problems. So let's do number 5. We are given that the interest is $3,600. We put $3,600 in there. The principal is $60,000. We are looking for the rate, and the time is 6 months, so we're going to express that as 6 over 12. Solving for R, the first thing we'll do is the 60,000 times 6/12, which is actually 30,000 times R. And now we'll divide to get R by itself. Dividing by 30,000 makes this 0.12 equals R, so that would be 12%. If you left it as 0.12 for 5, I'd be okay with that. Some people struggle with 6 and 7 as well. We have a 120-day, $12,000, 11% note, ordinary interest. At 65 days, the partial payment of $4,000 is made. So what's the note, the balance on the note after the partial payment? So we need to figure out the interest. 12,000 times 0.11, 65 days in, so it'll be 65 over 360. It was $238.33 in interest. That gets added to our balance of $12,000 before we subtract the payment. So we subtract our payment of $4,000, $8,238.33. For most of you that had that question wrong, it was right there at that point. So I'll let you guys try to finish that one off from there. Quick peek at 8 through 13. Most of you for 8 and 11 were able to successfully find the maturity value. I'm going to do number 11 here. So the maturity value there, we're looking at a principal of $50,000 times a rate of 12%. 120 days is 120 over 360. That will come out to be, was that $2,000? I believe so. Yeah. Sorry about that. There. So $2,000. So that means the maturity value is $52,000. So that would be number 11. Number 12, it was actually 9 and 12 that people made the mistakes on the most on this one. The discount period is the number of days left on the note. So if you figure out from April 5th to May 20th, that is 45 days. That's how many days have gone by. The discount period then would be the whole term of 120 minus 45, or 75 days. Then for number 13, the proceeds, you first have to find the discount. That discount is going to be off the maturity value of $52,000. It has a bank has a 10% discount rate that you see up at the top of the problem there, 0.10 times 75 over 360. That will give you the amount of the discount. You will subtract that from that maturity value to get the proceeds. Looking down 14 through 19. Any big questions there that you really need to see done? Okay. 18? Oh, okay. Either one of them? Okay. Let's start with 18, then we'll see how we look from there. 18 is an effective rate problem. You'll notice in the problem here, Joan Rivers deposits $4,000 in National Bank at 6% compounded monthly. What is the effective rate? It does not give a time because time doesn't matter. If we're asked for an effective rate and we're not given a time, we always assume 1 year. If we're asked for an effective rate and we are given a time, as long as it's over a year, we still only calculate for 1 year. So we need to find our interest. So at $4,000 at 6% for 1 year. What does that come out to be? $240? Correct? What did I do wrong? This is compound interest. 1 plus 0.06 divided by 12 to the power of 12. $42, $46, $71. So we need to figure out how much of that is interest by subtracting the original principal of $4,000. So we get $246.71 in interest. So now that's what we're going to use to find our effective rate. 246.71 equals 4,000 times the rate times the time of 1 year. I'm not going to bother to combine the 4,000 and the 1. We know they make 4,000. So I'm just going to divide by 4,000. So 246.71 divided by 4,000. 0.06177, so 0.06178. I said to always take it to 5 decimal places in the rates. Now I have to move the decimal over 2 spots, so 6.178. And this is asking round to, it doesn't say to round, so I'd say 6.18. Or no, so 6.16 it should say. So 6.17 is where that would round to. So if you had 6.2%, I would accept that, or 6.17%. 19 we can do pretty quick here. Jim Smith. Sorry, those are those reassuring sounds. Huh? Yeah. Those silly mistakes. It happens. Now, Jim Smith believes that in 10 years he'll need $50,000. So this is a present value problem. He's going to need $50,000 in the future. So it's going to be 50,000 divided by 1 plus 8% is 0.08, but it is compounded semi-annually. So we're going to divide by 2 because there are 2 periods in a year. The power of 20. 10 years at 2 periods a year will be 20 periods. Now this is when you actually could use the table in the book because that factor does appear in the table. Calculator tells us it is, oops, I did that wrong. There we go. 22, 8, 19, 35. So at 8% compounded semi-annually for 10 years, you would need to put away $22,819.35 today to reach $50,000. Questions? Okay, 20 through 25. Some of these I will work through. Some of these I am just going to identify which type. Now remember, there are two main types of problems here. The first one is if we are paying in. So we are paying in right now. So either we know the current payment, and we want to figure out what some future lump sum will be, or we know a future lump sum and we want to know what the necessary current payment is. Second type is when we're drawing out. This is our liquidation phase. Here we have a current lump sum of money, and we want to know what our future monthly payment or regular payment will be. So we can draw out of that in order to keep it going. Or the other way is to know the future regular payment desired and go back and figure out what that necessary lump sum is. Remember, this one has that little extra factor in it that we have to put into it. And I'll show you that when we hit an example. So let's start out now with number 20 on the test. Francis wants to have $300,000 saved up in 20 years. Now that right there should tell us what type of problem this is. Does he have the $300,000 now? No, he wants to have it in 20 years. So he is looking at a future lump sum. He wants to know how much does she need to put away each month. So we're looking for that regular monthly payment. What's the necessary regular monthly payment? So this is paying in. And we have the future lump sum. So when we have that future value, we take the future value divided by our factors. So it's 3 open parentheses, 1 plus. Our interest rate is 7%, so 0.07. And this is going to be monthly, so divided by 12. 20 years monthly is 240 periods, so the power of 240. And then our formula just says you subtract 1, close the parentheses, divide by, and open the parentheses. And since we're paying in, this is just the simple version here. 0.07 divided by 12, close and close. Now, if your calculator is like mine, some of you will have to use an arrow to get out of the power. And we get $575.90. Number 21. In number 21, Bobby has saved up $6,000 for retirement. Or $600,000. Do they have the $600,000 now, or are they looking to have it in the future? They have it now. What they are looking for is how much will she be able to draw out each month. So they want to know for what that future monthly payment will be. That regular monthly draw. They can pull out. So this is now drawing out. So we are going to have that extra factor in the end of our formula here. So we still have the lump sum, so we're going to divide it. So it's 600,000 divided by 1, 2, 3. 1 plus, our interest rate is 0.06. We're still drawing out monthly, so divided by 12, close parentheses. 25 years times 12 is 300 periods, so to the power of 300, minus 1, close parentheses, divided by, open parentheses. Now here's where we have the extra factor, 0.06 divided by 12, and then times 1 plus 0.06 divided by 12 to the power of 300, close and close. Comes out that Bobby will be able to draw out $3,865.81 per month. What do you think? Not so bad. Now for 22 and 23, we're just going to identify what types of problems we have. For number 22, if Ted puts away $250 a month for the next 35 years, how much will he have? Right now, he knows a current payment. He wants to know that future lump sum. So this is paying in. So that means we go up to that first formula for number 20. But instead of having the lump sum and figuring out the payment, we have the payment and we're figuring out the lump sum. So we would put the payment amount here and then multiply instead of dividing, and then the rest of it would be the same, of course, just changing the percents and the number of periods. So I'll let you guys figure that one out on your own. Number 23. How much does Fred need to have saved at 65 if he plans to draw out $2,900 a month? So here he knows how much he's going to draw. That's a regular draw, regular payment out to himself. He wants to know what he needs for a current lump sum to make that happen. So this is drawing out. And again, just like the last problem, this time they have the payment and they're trying to figure out what the required lump sum is. So we're going to use the same formula we did for 21, only we're going to have the payment in here of $2,900, that regular draw, it's going to be times instead of divide. And then the rest of it, just replace the percents and the number of periods. Any questions so far? I'm going to give you guys, let's do 8 minutes, 8 or 9 minutes to get you to 6 o'clock to work with what we've talked about so far. Then I will go over 24 and 25. What I'll do is I'll do one of them so you guys can see the pattern, and then you can do the other. 3 quick, and then we're going to take a look at 24 and 25. So for number 23, how much does Fred need to save at 65 if he wants to draw $2,900 a month for 25 years? So $2,900 times 1, 2, 3, 1 plus 0.09 divided by 12, 25 years is the power of 300 minus 1, close divided by open, 0.09 divided by 12 times 1 plus 0.09 divided by 12, the power of 300, close and close. $345, $345,568.70. Any questions? Okay, so I am going to do number 24. Now number 25 is actually easier because the interest rate is the same going both directions. It's 7% paying in and drawing out, so you don't have to change the interest rate. Number 24 you do. So we're going to do a little chart here just to figure out which way this is going. And remember, on each side you have a lump sum, a payment, so a lump, a payment, a percent, and a time. And we need to see which side we have both for. So for 24 wants to retire at 63. So 63 years old is retiring. Wants to draw out $3,200 a month. So that would be the payment on the draw out side. Wants to draw out $3,200. Estimates will live to 88. So there's our time. 88 minus 63 is 25 years. Draws 6% while drawing out and 9% while paying in, and is currently 28 years old. So 63 minus 28 is 35 years. So the side that we have 3 out of the 4 is the drawing out side. So we can find the lump sum. So that's where we're going to start. We're going to find that present value, which is the lump sum here. Over here, the lump sum would be a future value. So the present value is that $3,200 payment times 1, 2, 3. 1 plus 0.06 divided by 12. 25 years is how many months? 300 minus 1 divided by 0.06 divided by 12. Do we close the parentheses or do we have the extra term? We're drawing out, so we have the extra term. So times 1 plus 0.06 divided by 12 to the power of 300. Close and close. So that would give us a required lump sum of $496,661.96. So then that's the number we're going to use to start the second half of the calculation, to find the payment. So now that we know that lump sum, we can find the payment. So it's going to be divided by 1 plus 9% on the paying in side, so 0.09 divided by 12. 35 years is 420 months, minus 1, close, divided by 0.09 divided by 12. Since we're paying in, that is it. No extra term here. $168.83. That's what you need to pay in for number 24. So for 35 years, if you pay in $168.83 a month at 9%, you'll be able to draw out for 25 years $3,200 a month at 6%. Like I said, number 25, the percent is 7% going in both directions, so it's a little bit easier. Any questions? Okay, so I'll leave it for you guys to work on number 25 on your own when you get some time. What I'm going to do is I'm going to actually end this recording right here. I'll give you guys about 10 minutes or so to work. We will start lecturing again at about 6:28. So take your break whenever you want to here. At 6:28, we'll start talking about the extra credit.